Concentrator is a department charged with the responsibility of processing copper ore from copper ore into the final product, which we are calling concentrate. Apart from that, responsible for managing the tailings, sending the tailings, backfilling, as well as pumping the tailings to the dams for the safe keeping, for safe storage.
Welcome to this presentation from SEOB Concentrator. My name is Justine Chibwe. We'll begin our training by looking at the contents. Number one is the keywords and the brief explanation, organizational structure. Third, concentrator process overview. Fourth, major equipment and terms. Fifth is a shift supervisor responsibilities. Six is coordination with the other units. Keywords and the brief explanation. So number one is throughput. So throughput is the amount of ore processed by the plant per hour measured in tons per hour. Second is recovery. The percentage of valuable metal, which is copper, successfully extracted from ore during the processing. Number three is grade. Is the percentage concentration of copper in the final concentrate product. Number four is the reagent consumption. The amount of chemicals used in flotation, that is frother, collector, and line, per unit of ore processed. Fifth is density. The ratio of solids to liquids in slurry and usually measured in percentage solids or specifically gravity. Flotation is a process where air bubbles and reagents are used to float the variable mineral while the waste sinks. Number seven, reagents. We are simply meaning chemical additives, meaning the collector, the frother, the line, used to improve mineral recovery and the flotation performance. Number eight, the thickener. Thickener is a settling tank that concentrates slurry by allowing solids to settle and producing a clear overflow. Number nine, tailings. So waste material from flotation process sent to the tailings storage facility for disposal. Number 10, concentrate. The final high-grade mineral product recovered from flotation containing enriched copper. Number 11, operation pressure. Pressure level in equipment such as the cyclones, the pumps, and the pipes which affect separation efficiency. Number 12, the pH. pH is the measure of acidity or alkalinity in flotation circuits. Controls mineral surface behavior for effective separation. Airflow, number 13. The volume of air injected into the flotation cells to create bubbles for mineral attachment. Downtime. It is any period when the equipment or the plant is not operating due to a breakdown, a maintenance, or power outage. Number 15, safety permit authorization that confirms a task is safe to perform and usually under a permit to work (PTW) system. Number 16. So a control room is an operational center where the monitoring, parameter adjustments, and the process control takes place. Number 16. Process monitoring. Continuous checking of key parameters such as the density, the pH, pressures, levels, and the flow rates. Number 18, pumps. Equipment used to move slurry, water, reagents through different stages of the plant. Number 19, froth depth. Froth depth is the thickness of froth layer on top of flotation cells, affecting recovery and the concentrate grade. Then lastly, pH control. pH control is the regulation of acidity or alkalinity using lime or chemicals to maintain optimal processing condition. Next, as Concentrator Department will look at the organization structure, how the management is. So the topmost is the manager, followed by the concentrator superintendent and the assistant superintendent. On production side, followed by the general foreman. After the general foreman is the concentrator foreman, and lastly there is the ground plane operators. So backfilling is headed by the Chinese national. So that is on production side. From production, we move to the maintenance, mechanical engineer. Next is the piping engineer. From piping engineer, we move on to electrical engineer. What my highlight here is the instrumentation engineer. Next is the concentrator process overview. So from here, the stockpile, our copper ore is fed onto this CV3. CV3 is the belt, conveyor belt. Our copper ore from stockpile is fed onto this CV3 using the chain feeders. From there, this material is transported into the surge mill, semi-autogenous mill, where the milling is done. So when we say milling, we are simply saying breaking down these larger copper ore into smaller particles for processing. Here, the mixing of water, the mill balls, and the copper ore is done. After milling, after breaking into smaller particles, it is fed now onto the vibrating screen. So what basically this vibrating screen does is to separate. So the undersize goes on into the mill discharge tank. The oversize is retained, is fed on to the CV4. So from there, this undersize, the material which was fed into this mill sample, which we are more interested in. So this cyclone pump, what it basically does is to feed this material from the mill tank onto the cyclones there. The cyclones are also, I would call them separators. The cyclones will separate the overflow and the underflow. So the overflow will go to the flotation. The underflow will be fed back for further processing. From ball mill, it goes on to mill tank again. From there, from the cyclones, the overflow will come to the rotating screen. What this rotating screen basically does is that it removes the impurities, the waste, which we are calling here as a swaff. From there, our material down there to the conditioning tank, where lime, CPEX, and pine oil is added. From conditioning tank, after adding our lime, CPEX, and pine oil, from these two tanks which we are calling LAFA 1 and LAFA 2. From there, after collecting from LAFA 1 and LAFA 2, is fed now to the cleaners. So our material, our concentrate now is fed to cleaner 1, 2, 3 for further processing. The overflow from these two tanks is fed to cleaner 2, 2A, 2B for further purification. From there to cleaner 3A, 3B for further processing up to the final stage, which is cleaner 3 there, where we collect our concentrate. From there, our concentrate is fed to the concentrate thickener. From LAFAs, we'll go, the underflow goes to the scavengers. The underflow from scavenger 2B is what is collected now.
or rather finally, as the tailings. It is pumped to the tailings thickener at backfilling plant. Basically, this is the building which you are calling grinding. So this building is the one which houses both the grinding and the flotation. Next is a concentrate thickener. After collecting our concentrate is thickened here. From there, it is pumped into this other building. This is where the filtration takes place, and finally, the concentrate is stocked. That other building you are seeing there is the lime plant. Next is grinding and classification. Keywords: surge mill, ball mill, cyclone cluster, underflow, overflow, pressure, density. Grinding, reduce ore size, and the cyclones to classify fine and coarse particles. That is our surge mill, this is our ball mill, and those are the cyclones which we have earlier mentioned or rather discussed. So surge mill feeds the cyclone cluster, the overflow goes to the flotation. Also there's ball mill this side, ball mill feeds also cyclone cluster, then the underflow goes back to the ball mill. I talked about that cycle. Next is the flotation process. Keywords there: froth, lava, scavenger, cleaner, airflow, reagents, which is the collector, frother, and lime. Valuable minerals attached to the bubbles and are collected as the concentrate. That is under flotation process. So from the cyclone overflow, next is the conditioning tank. From conditioning tank, like I earlier mentioned, that is where we had the collector, the frother, and the lime. Next, after conditioning tank, is lava cells. From lava cells, it goes on to scavengers. From scavengers, finally, to the tailings, the waste. From lavas, after collecting our concentrate, further purified by the cleaner cells. From cleaner cells, that is where we get our final product, is concentrate. From concentrate, then taken or rather pumped to the concentrate thickener. That is about flotation process. Our important areas. So the first one which we are seeing here, this is the stockpile which I earlier talked about. Next, I mentioned about the chain feeders. What we are seeing here, those are the chain feeders. I also mentioned about the CV3, conveyor belt number 3. This is surge mill. And what we are seeing here, this is the ball mill. I also mentioned about the cyclones. What we are seeing there, that is the mill sump. Connected to the mill sump is this cyclone pump. The motor is there and the pump. So like I mentioned, it is here. Material is pumped from this mill sump, pumped on to the cyclones. So about cyclones, classify fine and coarse particles. Next is flotation cells. And here, this is the agitator. So the importance of these agitators is that what we are seeing there, that is an air pipe which introduces the air, pushes the air into the flotation cell, and here is the motor coupled to the agitator machine. Here, the material, when the material is inside the tank there, it is agitated. As the motor rotates, the material is agitated, and when the air is introduced, then you will have bubbles where the valuable mineral, the concentrate, will attach. We also talked about the reagent equipment. Keywords there: collector, frother, lime, reagent mixing, and dosing. Reagents control mineral recovery and selectivity. Here what we are seeing, this is our reagent plant. And basically what you are seeing there, that is our reagent machine, which is responsible for feeding the frother and the collector to the conditioning tank. In that building, that shed, that is where we stop or keep our pine or our frother. So our frother comes into the tanks. From there, we move on to the lime plant. pH modifier, that is lime. It is the one which conditions the materials into the conditioning tank. So what we are seeing there, this is where we stock our lime. And you've also mentioned about the ceramic plant or the filter plant. Ceramic filters wet concentrate. So these, what you are seeing, these are the filters which removes the moisture, or rather the water, from our final product concentrate. So the final product, our concentrate, is stocked here, is safely kept there as a concentrate. So here, this is the side view of a concentrate thickener. Lastly, after extracting our concentrate, I also talked about the waste, which we are calling the tailings or tails. So our tailings are pumped from concentrator plant after processing to this plant, which we are calling backfilling. The tailings are managed in two ways. Number one is that our tailings are pumped back after adding cement in this plant. It's pushed back to the underground after mixing the tails plus cement to backfill. Then secondly, we manage these tailings by sending them to the designated dams, which has been constructed by NFCA for safekeeping of tailings. A dam specifically constructed for self-disposal of these tailings called Musakashi. This is basically how we manage to dispose of our tailings. Either we take them to the ground after adding our cement, or dispose them off to the dams. From there, we'll talk about the responsibilities of a shift supervisor for Concentrator Department. Number one, safety briefing. A shift supervisor holds a short meeting at the start of the shift to remind workers about the hazards, the PPE, and the safety rules. Secondly, for walking through the plant to check equipment, housekeeping, to check on the leaks, noises, and the unsafe condition. A shift supervisor is responsible for assigning specific jobs to operators, attendants, and foremen based on a daily work plan. Number four, authorizing jobs like confined space, hot work permitting, logout, tagout, or working at height by ensuring all conditions are safe. Lastly, monitor production, checking throughput, recovery, grade, densities, process stability during the shift. As Concentrator Department, Concentrator does not exist on its own. It also depends on other units. So Concentrator is able to engage both internally and externally. So under internal coordination with other units, we have the Mining and Operation Department. So mining, they supply the ore and ensure quality is consistent for stable operations. As Concentrator Department, we also engage with the Supply Department on spares and consumables. Supply Department, they ensure that the plant has all the required materials and the spare parts to avoid the downtime. We coordinate with the Laboratory Department on grade and data recovery. So laboratory provides accurate grade and recovery data to guide the process adjustments. Concentrator engages the Environmental Department on tailings and water quality reports. They ensure tailings, water, and emissions meet environmental standards. Mine police provide security. They protect company assets and ensure security within the mine operation. So the safety department provides the safety. They oversee the safety practices and ensure the working condition for all employees. We are able to engage or rather coordinate with other units such as the Mine Safety Department. Sometimes they are called the MSD on a compliance audits. So MSD checks whether the mine is following all the safety laws and the standards. As Concentrator also we engage Ministry of Mines on documentation checks. The Ministry of Mines reviews documents to ensure the mining activities are properly authorized and are compliant. Thirdly, the environmental management, sometimes called the ZEMA. The ZEMA checks on the mine's impact on the environment and ensures pollution control measures are followed. I'll conclude by stating that Concentrator is the department charged with the responsibility of processing copper ore, from copper ore into the final product which we are calling concentrate. Apart from that, responsible for managing the tailings, sending the tailings, backfilling, as well as pumping the tailings to the dams for the safe keeping, for safe storage. So basically, that is about Concentrator. I thank you.